Okay, for this problem, we need to find out if it needs a free body diagram or not. It's not a dead giveaway because the question asks for the acceleration. So therefore, we have to count the degree of freedom. In this particular case, A is moving. If you stop A, then B can't move unless something breaks or goes limp. So therefore, it's 1 degree of freedom. That means that if you're given one acceleration, you can find any acceleration that you want. If you're given one acceleration in the freedom direction, which is up and down the incline. Okay, so in this case, we're not given an acceleration. Therefore, we have to draw a free body diagram. There are 2 bodies in this problem, and so odds are we're going to have to draw both bodies for the free body diagram. You do not want to put them together in a free body because they have different accelerations. A is going down, B is going up. Okay, so what I do here is draw the 2 free body diagrams. The first one, which is over here, is the free body of A. It has mass A gravity. It has 1 tension holding it. It has a normal pressure and a friction. Because it's sliding, the friction is equal to kinetic, and that's why you know it's 0.2 times NA, and you know the direction because it says that it's sliding downward, so friction opposes that. This diagram here is a free body diagram of B. Make sure that you have your pressures from A to be equal and opposite, which they are. The frictions are equal and opposite. And then you also have a tension, pressure from the floor, and the friction from the floor. Because it's sliding up, you know that the friction is trying to oppose that and holding down. Once you do that, you have to sum forces. The direction that you should sum forces is in whatever makes the acceleration easy. So that would be parallel with the incline and perpendicular to the incline. Okay, so for free body A, if down the incline is positive, you have the blue equation that gives you the forces in the incline direction. That's equal to the mass that's in the free body, which is 10, times the acceleration of A. I assume it's accelerating downward, but I don't know, or down the incline. And then the second equation here is the forces perpendicular to the incline. The acceleration of that is equal to 0 because it's not moving perpendicular to the incline. And then the equations over here are the forces in the for free body B, and down the incline is also positive. In this case, I'm also assuming that acceleration of B is also down the incline. So I'll get a positive if it's true and negative if it's false. I'm expecting that it'll be a negative number because the problem says it's going up. Okay, and then the second problem, or the second equation here in blue, is the forces perpendicular to the incline. All right, then what I do is I circle the things that are unknown. So you can see that there's 5 unknowns here, and there's only 4 equations. So you can't solve it. You need something else. If you notice there are 2 unknown accelerations, you should not have 2 unknown accelerations because it's a 1 degree of freedom. So once you know one of them, you automatically know the other one. That is what tells you that you need a rope equation. So we'll pause for a moment, come up here and do the rope equation. It's going to be in green. Step 1 of the rope equation is you label a distance to all of the things that are moving. So I label a distance YA and a YB. Then what you do is you add up the length of the rope, ignoring any constants. And that gives you this equation right here for the rope. Then you take 2 derivatives because I'm looking for acceleration. So I take the 2 derivatives and that gets me this one here. It's equal to 0 because the rope is a constant length. Then what I need to do is relate the y double dots to the accelerations. If YA gets bigger, if you look at the picture, if YA gets bigger, it's going down the incline. and down the incline is called the positive acceleration of A, right here. So that was a down the incline. I assumed it was going down. Okay, if YB is getting bigger, then B is going down the incline, and down the incline is what I called positive acceleration of B. So the YA double dot equals the acceleration of A, and YB double dot is equal to acceleration of B. So I bring that equation back down here. Now I have 5 equations and 5 unknowns, so I can solve for it. Okay, so I bring this equation right here down, and I solve for t, just some algebra. Incidentally, I brought this one down, I guess I should say that, and I solve for NA. I bring this other one down here, and I solve for NB. So I solve for NA and NB. Then I bring down the this blue one here. So I bring him down, solve for t, and then just a little bit of algebra, simplify it a little bit. Then what I'm going to do is I'm going to bring down this other equation that has, this one. I'm going to bring him down, and I'm going to plug in for the t. So this is t. Actually, it's minus t, if you notice. Minus t. So minus t comes in here. So that's the negative t. And then I just copy everything else down. I put in a few numbers that are known. For example, I know the ends, and that gets me that equation. Okay. So then I just, a little algebra, add everything together, take the A term over to here, contribute it over there, and just solve for acceleration of A. From this other equation right here, acceleration of B is opposite the acceleration of A. It's not asked for, but I went ahead and solved for t anyway, and t is 31.31. Now, the fact that this sign right here is negative, what it tells me is that I was wrong about the direction I thought AB was. When I wrote the equations up here, I thought it was going down the incline. The negative says I'm wrong, and so it's therefore going up the incline. So then I just added up here. The magnitude is the absolute value, and it's going up the incline. Okay, that's it for that one.